Hi, good evening to all. Tell me how's your coding journey is going on. Tell me one thing, am I audible to all? You guys can hear me? Let me know in chat. Am I audible to all? I'm looking at the chats. I'm looking at the chats. Tell me. Good evening to both of you. Prince Pandey, EX1. I hope you guys are preparing the question after the lecture. Tell me one thing, am I audible to everybody? Am I audible? Because today the question that we will discuss is super important because that has been asked, I guess, in every MNC, including Microsoft, Google, all the FAANG company, Amazon, Apple, everywhere, repeatedly, a lot of time. Because there's something important in this question, that's why it has been asked in multiple companies. Okay. And I hope after these lectures, you guys, try the code by yourself. You try to put different input. You try to dry run it, right, to understand, to get the maximum of it. Okay. Now let's continue. Again, we know about the series, right? And yeah, all of you can see the playlist as well. All these videos are going to a playlist which is LeetCode series, a playlist. You'll go to the playlist section, you'll get the playlist of this as well. There you can see the the videos which you may have skipped. Okay. Now I'll go to the LeetCode. I'll tell you the problem statement, and I want that anyhow you should understand this because this is a super important question. It already has been asked in a lot of companies. I guess in all the MNCs. So now, because when I was doing research on it, I've seen that around more than 20 companies I've checked by myself. It has been asked multiple times, repeatedly. So now we'll search for the problem statement, maximum subarray. Maximum subarray. So we will get a question which is maximum subarray. This one. Okay. We'll take a 30-second break to understand this, what problem statement is. That telling like, given an integer array nums, find the subarray with the largest sum. Okay, so now here the term subarray. What is subarray? So subarray is a sequence of elements. Okay, let's say -2 is a subarray. Again, -2 comma 1 is a subarray. Again, -2 comma -3 is a subarray. 4 comma -1 is a subarray. So any part of contiguous part of the array, subpart of the array, is a subarray. Okay. Okay. Now, cool. So now what we need to get is that the largest sum of a subarray, largest sum, the possible largest sum. Okay, so now how we can approach this problem? We talk about the brute force method. Okay, brute force means a simple easy peasy way how we can attempt this. So I'll go to the whiteboard to make you understand, like, if we want to implement very super easy solution, so then what it can be. Okay, I'll change the color as well because I know you people don't like red. I'll go for yellow. Okay. Okay. Maximum subarray, right? So this is the problem statement. Maximum subarray. And let me know if you're having doubts in this. Because trust me, this question is super important. Maximum subarray. Okay. Maximum subarray. So now the first term was subarray. How we can calculate subarray? So subarray means any subpart of the array. So let's say we have an array 1, 2, -2, 3, 4. Okay, so we have this part, and again, if somebody will ask me the subarray, so the contiguous means without leaving any elements. So this is a subarray. 2 itself is a subarray. Again, -3, 2, 4 is a subarray. Each 1, 3, 4 is a subarray? No, this is not a subarray. It's a subsequence, not a subarray. Right? It's not a subarray. Sir, in this problem, there must be a value of k, maximum element that can be taken. No, it's actually, They haven't defined. The number of element are not defined already. They can be anything. So what we need to find is that means even the whole array can also have a maximum sum. Even a single element can have a maximum sum. Okay, so that's what they have mentioned. That's what they have mentioned. So now again, how we can calculate this? How we can calculate this? So I'll take the input value from the problem statement. Any easy one here because this is too large. I don't want to copy paste it. This is sounds good to me. 5 4 minus 1 7 8. 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 So these are 5 values. Okay, we need to find out the maximum subarray. So let's starting psi. Okay, so now let's say in starting we are assuming that say this 5 is the maximum sum of the subarray. Maximum sum. Again, what we will do, we'll add the next element. Again, we'll check, is this greater than the previous maximum subarray? So maximum sum, I'm assuming this is a maximum sum. Okay, maximum sum. I'm assuming. I will add the next element. You know what can be the easy way, right? Previously, I'll calculate the all the sum of all the array element, right? From this to this. So this will be what? 5 4 9, 9 minus 1 8, 8 and 7 becomes 15, and 15 and 8 becomes 23. Is it so? Right? Again, so now another subarray can be this. I'll take this. So now what can be the sum? 4 minus 1 becomes 3. 3 is 7, 10, 10, 18. So now what is the maximum sum? Still, this is maximum sum, right? Again, I'll take minus 1 and 7 and 8. Okay. So now what will be the maximum sum? The maximum sum can be, minus 1 and 7 becomes 6, 6 and 8 becomes 14. Again, I'll take this one. So now this becomes what? This becomes 8, 7, 15. Again, I'll take the 8 itself. Right? So these can be the subarrays, the possible subarrays. Yes or no? Now another what can be possible? What we can possibly say, like if we take the subarrays by leaving one characters like this one, 5 4 once, then again 5 4 1, then again 5 4 7, then again 5 4 8. That we already done, right? So these we can do with the help of two loops: an outer loop which will start from here, an inner loop which will get you the sum. But in that case, you can write a brute force, okay, an outer loop and an inner loop to get the sum. So what will outer loop will do? It will get you the each and every element, and again the inner loop will give you the sum. And every time you will calculate, and whatever the maximum value you will get, you will return. But what the problem with this solution is, this will give the time complexity of n square, big of n square, because it will run the both of the loops n times, right? So it becomes n square. So what will happen for the very, very large input values? You will get the error TLE, time limit exceed. Time limit exceed. So that is not an optimal solution, right? So what will be the optimal solution? How we can approach this problem? So here is the concept of dynamic programming. Or I don't want to add these heavy terms here. I'll tell you very easy peasy way. Okay. So now what can be the another solution? I'll take the input values again. Here 5 4 minus 1 7 8, right? 5 4 minus 1 7 and 8. I'll take this input value. What I can assume is, I can say this is a value. I'll assume the first element of the array is a maximum sum. Okay, maximum sum. I'm assuming, and it's also a current sum. Current sum, because I will take the window of sum. Okay, and again what I will do is that I will add a next element to the current sum. Means I will add 4 to the 5. So now this becomes 5 plus 4, which is 9. Which is what? Which is 9. Again, there is a possibility, what if this wasn't a plus 4? This can be a minus 6 itself. This can be a minus 6 itself, right? So in that case, what you will see is that what will happen, that what I want is, I will get the current sum, which means the next element sum, the addition of the next element, but also I will compare to the current element as well. Because what if the sum is less than the current element? So in that case, that current element is a maximum sum. You getting my point? let's say I'm assuming, I'm telling like this is not 5, this is minus 5. Okay, so previously we have assumed this minus 5 is a maximum sum and minus 5 is a current sum. Next time what happened is the next element came to us, we got the addition, so which is minus 1, which is minus 1. But at this window, can we say this 4 was itself is a maximum sum? As compared to minus 1, 4 was greater. 4 could be a maximum sum. Yes or no? 4 could be a maximum sum. And that should be also. So whenever you calculate the current sum, you will calculate the current sum by adding the next element. But also you will compare that current sum by what? By the current element. The current element. And whatever is greater in the both, the sum of the next element and the current element, whoever is the greater, you will assign to the current sum. Will assign to the current sum. Okay, and at the end we will compare this current sum to the maximum sum. If current sum is greater than the maximum sum, then we will update the maximum sum. You getting the point? If current sum, if current sum is greater than the maximum sum, we can say we need to update maximum sum. Yes or no? If this current sum greater than maximum sum, we can say we can update the maximum sum by current sum, because maximum sum is holding the maximum value. Yes or no? We should update this. We should update this. So what can be the logic? So logic can be something like, initially we will assume the first element as a maximum sum and current sum. Then we will keep calculating the current sum and we will keep comparing with the current element. Whatever is the greater, the if current sum increased by adding next value, then we will update the current sum with that updated value. Otherwise, we will assume the current value as a current sum, right? And then we will compare the current sum to the maximum sum. Okay, maybe as of now you're not getting the context, but once it will come to the code, you will get to know. Okay, you will get to know like what I'm telling to you. Okay, now here we go. Here we go. And again, I feel like now every day we are seeing around same students, the number of same students. Yeah, at least share the video links or whatever the live link. Every day I come at 6:15. So you know that, right? You can share with your friends as well to join this. Maybe this can help them as well. Right. So now what we were assuming, we will have two variables, like the first one is current sum. So I'll define current sum up to what index? To the last index as well. It is possible to the last index as well. I'll dry run this to make you understand. And that's why this problem statement, has been asked in multiple companies, even in every top MNC, including Google, Microsoft, Netflix, Bloomberg, in a lot of companies, a lot of. Okay, so current sum equals to what we were assuming, the first element of the array, which is 0, the first element at the 0th index. I'm also assuming the maximum sum, I'm also assuming the maximum sum is the first element, okay? And we'll update whenever we'll get the greater value than this, okay? And I want to run it from where? And I equals to 1, because 0 we already assumed. So we don't have to define 0 here, right? So now I is less than till what? Nums.length. Make sense? Now I plus plus. I plus plus. Now what I will do is that I'll calculate the current sum, right? SUM, current sum, and current sum will be the maximum value of what? Maximum value of the current sum means by adding the next element or the element itself. Whoever is the greater, that will become the current sum. So now, which means current sum, which means the previous value, plus next element will be nums I. Yes or no? Nums I and the element itself, because maybe the element is greater than the sum. Then in that case, that element is current sum. We want larger value, we want maximum value, right? So in that case, that will be the greater value. So that's why we're comparing with the current value itself. So now again, we got the current sum. My battery is low, yaar. Oh, thank God you reminded me. Just give me a second, huh? I'm changing it. And then tell me, am I audible to everybody? Battery was low of this. I'm changing the mic. Now tell me, am I audible? Tell me, am I audible to all? Let me know in chat. Let me know in chat. Am I audible? Okay, cool. Thank you, everybody. Okay, cool. Now, what I was telling you that I will calculate. What? First, I will calculate the sum of the next element, which means whatever the current sum we have, we will add the next element, right? And then again we will compare the element itself, because maybe the element is greater than the sum. And anyhow we want maximum sum, right? We want maximum sum. So that's why we are comparing with the current element itself. If the current element is greater than the previous valued sum, so we will update the current sum to that individual element. Okay. Now at the end we will compare this maximum sum with what? With the current sum. So if current sum is greater than the maximum sum, we will get the updated value of the maximum sum. But if it's not, then maximum sum is the maximum sum. Yes or no? Right? And at the end, we will return, and this is the one of the best optimized solution, right? Because there is no repetition. So now we will return the maximum sum. We will return the maximum sum. Cool. So I'll try to run it. Maybe it worked fine. No, yaar. Okay, it's a nums, not a num. Where we have written? It's a nums. Cool. Anything else? Cannot find variable num. Maximum sum equals to here. This is also nums. Because here nums has given, right? Not num. Okay, now cool. We'll run it again. We will run it again. And let's see. It's working fine. And I'll dry run as well to make you understand. I will dry run this by putting the different values. And I want that you people also do this. It's a good perfect solution. The time complexity is what? It's a linear big of n. Okay, it's a linear big of n because you're running only one loop. You're running only one loop. So now here let's pass the input values. Okay, now let's pass the input values. So now again what I will do the comments here as well today. Today I'll do the comments here. Okay, to make you more understand like how this is working. Okay, so now here what will happen? The current sum value, because we are assuming 0 index, so we will get -2 as of now. Similarly, for the maximum sum, we will have the same value. Yes or no? We will have the same value, -2 and -2, because we are assuming to the 0 index. Yes or no? Now we are running this loop to the end of the array till the length of the array. So now how is this working? We are starting from one index. Why? Because this already has been taken, as we already initialized, right? So we don't have to take this. What we can do, we need to calculate for this, right? So now we are starting from I equals to 1, which is this. It will run till the length of the array, and now again every time it will increase by 1, I plus plus. That you already understand, right? So now what is the current sum? The current sum is the previous value, which is what here? That is -2 plus nums I is 1, and at one index you are getting 1. So -2 plus 1 becomes what? -1. Tell me at the very step 1, I'll comment here. At the step 1, what will be the current sum? Okay, current sum, I'll write CS, current sum. You'll get to understand, right? So now previously current sum was -2 plus 1, or this becomes what? -1. So now tell me, is 1 is greater or -1 is greater? So who should be the maximum sum? That is 1 itself, right? So that is the purpose of writing here nums I. So now we will get the current sum as what? Because we are comparing -1 and 1. We will get current sum as what? We will get current sum as 1, not -1. Because 1 is greater than the -1. You're getting my point? Right? Because that is greater. So that's why we are updating the current sum. Now what will happen? We'll come to here. We will compare, is maximum sum was -2, yes or no? Already assigned. And the current sum is what? Current sum is 1. So what will be the maximum sum? Tell me. What will be the maximum sum? I'll write MS for maximum sum. So maximum sum now it will be 1. because whatever is the greater in both, math.max will return only that one, right? So now the maximum sum is 1. In the step number 2, what will happen when you have reached to the end of the loop, I plus plus, which means now I is 2. Now I is 2. So in step 2, tell me what will happen. In step 2, what will happen? In step 2, what will happen is that you'll update the current sum again. So the previous current sum value was 1, which is 1. This is here. And at I is equals to 2, you will get minus 3. Minus 3. You will update 1 minus 3, which means minus 2. And the current element is minus 3. So what will be the value of current sum? Tell me the value of current sum. It is 1 plus minus 3. Yes or no? Minus 3. So this will result to minus 2. And again nums I is minus 3. Right? So we will not update it. So now what will be the current sum value? Current sum value will be because minus 3 is less than the minus 2. So we will update the current sum to minus 2. And then what will be the maximum sum? Because still maximum sum was 1, which is greater. So the value of maximum sum is 1 here. Yes or no? Now we'll write step 3. Keep engaging, otherwise you'll feel sleepy. Keep engaging. Okay. So now in step 3, the value of current sum will be, and again, if these problems, would be super easy, so everybody would have a placement in the top MNC, right? They are tough to understand. You have to spend a lot of time on them. You have to be consistent. You have to be patient, right? So now CS. So the current sum value will be what? Now we have I is equals to 3. So at I is equals to 3, which is 4. Which is what? Which is 4. So the current sum will be, previous current sum was minus 2, and minus 2 plus 4, which results to plus 2. Yes or no? And the current value is 4. So who is greater? 4 is greater. So we will get current sum as what? Current sum as 4. Why? Because nums I was greater, this was greater, so we will get the current sum as 4. Yes or no? Cool. So now tell me what will be the value of maximum sum. We will come here, we will compare. Maximum sum previously it was 1, current sum is 4, so we will update the maximum sum and this will becomes 4. Yes or no? This will become 4. Now at step number 4, what will happen? I plus plus. Now the value of I is 4. The value of I is what? The value of I is 4. Now what will happen? We will update the current sum. Previously the current sum was 4. So now 4 plus, and at the 4th index we have minus 1. 4 plus minus 1 becomes 3. And the current value is minus 1. So what will be the current sum? The current sum which previously was 4, and 4 again, what will happen? We'll do plus, and in bracket we will get the minus 1. Right? This becomes 3. But in nums I, which is minus 1, so the current sum will be 3 itself, because we are using math.maximum, whatever the maximum value of it. Now we will calculate the maximum sum. Right? We will calculate the maximum sum. Tell me, maximum sum will remain 4. Yes or no? Because we will give you the maximum value out of this. But maximum sum is 4, current sum is 3. We will not update it. So maximum sum will remain maximum sum. Now what will happen at the end? We will get the I plus plus. Tell me one thing. Are you understanding the solution? How it's working? Now the current sum will be what? The current sum again, we will get the I equals to 5, and which we will get again 2. At the 5th index we have 2. So the value of current sum will be, previously it was 3. So 3 plus 2, which means 5. And the value of current element is 2. So what will be the current sum? Current sum will be 5. Yes or no? Because of math.max. So the current sum is 5. And if current sum is 5, then maximum sum will be updated. Maximum sum will be what? Again, it will be 5. Now again we reached end of the loop. Now again we'll write the step number 6 when I is equals to 6. So at I is equals to 6, what will be the current sum? Tell me. The previous current sum was 5. And again at the 6th index we have 1. So 5 plus 1 becomes what? 5 plus 1 becomes 6. So what will be the current sum value? Which is 6, because the nums I is 1, current sum is 6. We will get the maximum value, so current sum is 6. Yes or no? So what will be the maximum sum? Maximum sum will be 6. And now we are getting the maximum value of the both. So now again we reached end of the loop, and what we will get? Tell me. step number what? Step number 7. And at step number 7, we will get the current sum, and current sum will be what? Tell me. Previously, current sum was 6. So 6 plus at I is equals to 7, what we have? We have minus 5. So now 6 plus minus 5, and this will becomes 1, right? Yes or no? This will become 1. And now the value of current element, which is what? Which is minus 5. So anyhow, what we will get current sum as, which is 1, because 1 is greater than the minus 5. So the current sum is 1. And the maximum sum, tell me what will the maximum sum? It will again 6, because it will not be updated. We will have the maximum value from it only, right? Now at step number 7, after step number 8, right? Now step number 8 after 7. So now here the value of I becomes 8, means we are at the last value. So now the value of current sum will be what? Tell me. The value of current sum will be 1 plus what? 1 plus 4. And this becomes what? This becomes 5. So which means the value of current sum will be 5. Yes or no? Then what will be the maximum sum? Maximum sum is 6, because 5 is not greater than 6. So it will not update it. So now at the end, what happened is that again I has been incremented. Now I becomes 9, which which is greater than the length of this, right? So now, which means equal to the length of this, means there is no element on that length. Now the whole solution is done. So this is the one of the best optimized solution which you can try. Okay, and I hope you understood this. Brute force will not work because of the larger inputs. We will get the TLE, time limit exceeded. Okay, and again, yeah, to understand DSA, to really do well in LeetCode and other coding platforms, you have to consistent. There's only one way to be legend of it, be the top 1% coder, or be the super successful engineer. There is the continuous commitment for problem solving and consistency. That is super important. Okay, so now I hope you understood the problem. See you in the next live. Bye bye. But I request you hardly that keep doing the practice of it. Keep putting different value and keep trying on it. Okay. Bye bye all of you. I hope you enjoyed the session. Bye bye to all.